channel of Digital to Real. Today we will discuss about the Verilog code of clock generator. हम Verilog code clock generator के बारे में discuss करेंगे. अच्छा, what are the properties of a clock? So we talk about the frequency of a clock. We talk about the duty cycle of the clock. We talk about the clock phase. That is the phase of the clock in relation to other clocks. So the key properties of a digital clocks are its frequency, which determines the clock period, a duty cycle, and the clock period. The frequency of a clock, what does it indicate? It indicates how many cycles can be formed in a certain period of time. Mostly we take the certain period at second. How many cycles of the clock are possible in 1 second? You see here the clock. You see? We are having the square shaped clock. For 50% of the time clock is up. 50% of the clock is down. Okay? And here we can see the clock period. You see, 50% of the time the clock is up and 50% of the time is clock is down. From this point to this point, it is called the clock period. This was by mistake I have done. I have nullified this one. Okay, don't consider this. This one is the clock period. Now, clock duty cycle. So what is the meaning of clock duty cycle? The amount of time the clock is high compared to the time period defines duty cycle. Means earlier in the waveform what we saw, 50% of the time clock is high, 50% of the time the clock is down. Up and down together they form the clock period. Now here we have 3 clocks, okay, stream of clocks. In first one you see the clock remain high for a small duration and it remains low for a high duration. So if I consider first one, clock is high for very small duration, it is down for a long duration. If from this point to this point is the clock period, then it is the clock is on for this much time. Suppose this from this point to this point, if it is 100, clock is on for 25. So 25 divided by 100 is equal to 0.25, that is 25% is the duty cycle. Here you see, here clock is on for 50% of the time and the clock is down for 50% of the time. So this point to this point, if it is 100, 50 by 100 is equal to 0.5. So 50% duty cycle. Here the clock is on for more longer time, it is down for less time. So from this point to this point, if I consider it as clock periods, the clock is on for 75% of the time. 100, this is 75 value if you take. 75 divided by 100 is 75 divided 0.75. So 0.75 is equal to 75% of the duty cycle. Now we talk about the clock phase. If one cycle of the clock can be viewed as a complete circle with 360 degree. Suppose we have here the clocks, okay. From this point to this point we will consider as 360 degree. 360 degree. Okay, 360 degree, how it forms? 0 to 90, 90 plus 90, 180, 180 plus 90, 270, 270 plus 90 is 360. So if one cycle of the clock can be viewed as a complete circle with 360 degree, another clock can be placed at a different place in the circle that occupy a different phase. Now I will show you with the example. 0%, 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. For the first stream of clock, it is starting at this point. Second stream of clock is starting after 90 degree. Okay, from this point. Okay. And third stream of clock is starting at 180 degree at this point. Okay. So this clock is shifted by 90 degree. This clock is shifted with respect to the first clock by 180 degree. Okay, and it is shifted with respect to the second clock by 90 degree. Actually, this point is aligned to this point. This point is halfway, half of this first clock, and it will go down till this point. Okay, so this one is with respect to first clock. If I take, it is 90 degree shifted. This is with respect to first clock I take, it is 180 degree shifted. Verilog code of clock generator. तो अब हम क्या करेंगे, Verilog कोड लिखेंगे क्लॉक जनरेटर के लिए. So in order to write the Verilog code, we also need to know the simulator for which we are writing the Verilog code. And Verilog code on a particular simulator runs on a time scale directive. Okay? तो हम सिमुलेशन जब करते हैं Verilog कोड का, हम एक पर्टिकुलर सिमुलेटर के लिए काम करते हैं. तो अब हमें सिमुलेटर के लिए हमें टाइम स्केल डायरेक्टिव स्पेसिफाई करना पड़ता है. टाइम स्केल डायरेक्टिव डज व्हाट? इट टेल्स अस द टाइम प्रिसीजन. क्योंकि हम क्लॉक प्रोवाइड करते हैं टेस्ट बेंच के थ्रू डिज़ाइन में. अब क्लॉक एक सर्टेन फ्रीक्वेंसी होता है, उसका एक सर्टेन टाइम पीरियड होता है. ठीक है, जब इतनी स्मॉल डिटेल्ड वर्क हम करते हैं तो हमें चेक करना पड़ता है वेदर आवर डिज़ाइन कैन वर्क ऑन दैट प्रिसीजन और नॉट. In order to do so, we have the time scale directive. Okay, जो टाइम यूनिट्स होंगे जैसे #1, #10, #15, वो टाइम यूनिट कितना है? The unit is a measure of the clock cycle. The tick time scale compiler directive specifies the time unit and precision for the modules that follow it. So हम कंपाइलर डायरेक्टिव टिक टाइम स्केल जो यूज़ करते हैं वो हमें बताता है टाइम यूनिट और प्रिसीशन, जिससे जो मॉड्यूल हम वेरीलॉग में लिखेंगे दे विल वर्क. क्लॉक जेन आपको डिस्क्राइब करूँगी, where we will have the enable signal as the input. Okay, and via this signal, via this enable signal, we are going to generate multiple clocks from a single clock. Tick time scale 1 nanosecond by 1 picosecond. So यहाँ पे देखो हमने precision आपको provide कर दी टाइम स्केल डायरेक्टिव के थ्रू at the beginning of the Verilog code. Tick time scale 1 second by 1 picosecond. So 1 picosecond is the smallest unit of measurement we can have. It is the smallest precision. We cannot go below that one. Okay. So module clock gen. So clock gen is the name of the module. Input of the module is enable and output of the module is clock. Already I have specified the output is of reg type. Clock is of register type. Now we are specifying 3 parameters here. One is the parameter frec. That is the frequency measurement is given in parameter frec. I have provided 1 followed by 50, that is 1 lakh kilohertz. In kilohertz we have put the comment. Then the parameter is phase. What is the phase of the clock? Here I have provided at 0 degree. Parameter duty. What is the duty cycle of the clock? That is put it as 50. The 50 tells me the percentage of the duty cycle. These are 3 parameters which we can change from the test bench. Okay. Now we are having a clock underscore PD variable. Okay. And what is the type of the clock underscore PD variable? It is a real. Type is real. Means it can hold integer as well as the floating value. So clock underscore PD is equal to, okay, 1 divided by, that is the clock period, how we measure? 1 divided by frequency tells me the clock period. As as the frec, which is a parameter specified from the test bench, is in kilohertz, so I have put 1 divided by frec into 10 to the power 3. So 1 divided by frec into 10 to the power 3, whatever the value will come, it is multiplied by 10 to the power 9 in order to get the clock period in nanoseconds. Variable clock underscore on, it is of real time. Variable clock underscore off, it is of real time. Variable quarter is of real time. Variable start underscore delay is of real time. Variable start underscore clock is of reg time. Now you see, clock on means what? The duration of time. The clock is at the upper value, is high. How we can find it? We can find it from the duty cycle. Duty cycle is a parameter. We will change it from the test bench. So duty divided by 100.0 multiplied by clock underscore PD will give me the clock on period in nanosecond. It is of real time because it can hold integer value and float. Clock underscore off, that is 100 minus duty whole divided by 100 into clock underscore PD. Okay, that is the clock off. It is also of real time. That will tell me the duration of time for which clock is in lower position, clock is off. It is 100 minus duty cycle divided by 100 into clock underscore PD give me the clock off period in nanosecond. Now quarter. Quarter is equal to clock underscore PD divided by 4 semicolon, that is of real time, quarter. Start underscore delay, it is also of real time, quarter into phase divided by 90 is equal to start delay. So quarter means what? 1 by 4 means quarter. Quarter of clock period means what? 1 by 4 multiplied by clock period give me quarter. That is what is written. Real quarter is equal to clock period divided by 4. Now, suppose I am generating multiple clock. If I need to generate the starting delay for 90 degree shifted clock with respect to the first clock, how I will determine the delay, start delay? It will be quarter multiplied by 90 divided by 90, here it will be for 90 degree phase shift. If it is 180 degree, phase will be put it as 180 divided by 90 into quarter, 2 times the quarter value will come as the start delay. Similarly for 270 degree phase, 270 degree divided by 90 into quarter, 3 times the start delay. A 0 degree phase shift, 0 divided by 90 is 0 into quarter is 0. There is no start delay. Okay, and then we have reg, that is the start clock. Verilog code which I am writing, जो Verilog code मैं लिख रही हूँ, that is not a synthesizable code. वो synthesizable code नहीं है, क्योंकि initial begin block, ये जो मॉड्यूल है initial begin block जिस मॉड्यूल में है वो synthesizable नहीं है, क्योंकि initial begin end synthesizable statement से नहीं है. So this Verilog code is meant for simulation. Here I have put $display statement in order to keep a track of how the simulation is going through. Are we in the correct path or not? We have put multiple comments, multiple displays. This is how actually coding happens. So you see, I have put display for frec. डबल कोट्स के अंदर है फ्रैक इज इक्वल टू परसेंटेज डी किलोहर्ट्ज कॉमा फ्रैक सेमीकोलन. देन नेक्स्ट स्टेटमेंट इज परसेंटेज डी ब्रैकेट अंडर द डबल कोट्स आई हैव फेज इज इक्वल टू परसेंटेज डी डिग्री कॉमा फेज. देन आई हैव पुट परसेंटेज डॉलर डिस्प्ले ड्यूटी इज इक्वल टू परसेंटेज डी inside double quotes is duty. Dollar display period is equal to percentage 0.3. F is the floating point. These are the various format string. Nanosecond. Clock period I have put it at percentage 0.3 F nanosecond. For clock on also I have put it as percentage 0.3 F nanosecond clock on. Clock off I have put it as percentage 0.3 F nanosecond clock off. So these are all 3-digit precision after the decimal. So that is what now dollar display quarter is equal to same percentage 0.3 F nanosecond. These are under double quotes, comma, quarter, semicolon. Dollar display under the double quote percentage double quote start underscore delay is equal to percentage 0.3 Fn, comma, start delay n. This is the end of the initial begin. So this is how displays have been put. Now we will initialize the variables to 0. There is another initial begin end block inside which I have put clock is equal to 0. Non-blocking statement is there less than equal to symbol has been put for assignment purpose. Start underscore clock, that also has been put as 0. Start is of reg type. Start clock is of reg type. Clock is also of now reg. Here double slash, it means comments. So I have put the comments which says when the clock is enabled, जब clock enable होगा, delay driving the clock to 1 in order to achieve the phase effect. So जब clock enable होगा, हम delay provide करेंगे clock को, जिससे कि हमें particular phase effect मिले. The start delay is configured to the correct delay to configured phase. जो start delay हमें mention किया है वो correct delay है. start delay है, उसको हम कैसे mention करते हैं, calculate करते हैं based on the phase parameter, और वो correct delay होता है for a particular phase. हम multiple clock generate करेंगे for different clock frequency, different phase and different duty cycle. For that purpose, we have start delay also, which comes into place when we want to have multiple clocks of different phases. When enable is 0, it allows enough time to correct current clock period. जब enable आपका 0 है, हमारे पास enough time है clock period को complete करने के लिए. देखो, अब हमारे पास always block है. Always at inside the bracket I have pausage of enable और negage of enable begin, and then begin के लिए end भी है और always के लिए भी end है. तो pausage of enable और negage of enable, what does it mean? It means that the always block is sensitive of positive edge of the enable or the negative edge of the enable. 0 to 1 transition or 1 to 0 transition. Enable is the input to this module of clock gen. Okay, and output is the clock, that is of reg type. So if enable begin, so it means अगर enable high हुआ तो, if the enable is high, then I will wait for hash start delay and then start clock I will put it as 1. हमने start clock और clock को initialize कर दिया था 0. अब अगर enable high हुआ तो मैं start delay time unit के लिए wait करूँगी. That will be calculated from clock period and phase. Okay, और फिर start clock को I will set it as 1. And if the enable is 0, there also I will wait for start delay time unit, and I will put the start clock to 0. So we generated the start clock. Start clock को हमने कहाँ से जनरेट किया था? Enable इनपुट से. जो आपका इनपुट है मॉड्यूल का, उसके ऊपर मैंने बेस करके स्टार्ट क्लॉक जनरेट किया था. स्टार्ट क्लॉक का ऑन एंड ऑफ पीरियड हमने कैसे पता किया था? स्टार्ट डिले से, जो हमने फेज ऑफ द क्लॉक से इवेल्युएट किया था. अब मैं एक्चुअल क्लॉक जो आउटपुट है उसको जनरेट करूंगी बेस्ड ऑन द स्टार्ट क्लॉक. ओके, अब मैं फेज शिफ्टेड क्लॉक को कैसे जनरेट करूंगी स्टार्ट क्लॉक से, ये देखो आप. ऑलवेज एट पॉजेज ऑफ द स्टार्ट क्लॉक, मतलब मैं ऑलवेज ब्लॉक के अंदर एंटर्ड करूंगी जब स्टार्ट क्लॉक 1 है. ओके, अब एंटर होने के बाद अगर स्टार्ट क्लॉक कंटिन्यूअसली 1 है, मतलब मैं एंटर कर रही हूँ ब्लॉक में एट पॉजेज, मतलब 0 to 1 ट्रांजिशन ऑफ द स्टार्ट क्लॉक के टाइम. अब जब आपका क्लॉक स्टार्ट क्लॉक 1 है तो मैं क्लॉक इक्वल टू 1 सेमीकोलोन पुट कर रही हूँ. वाइल स्टार्ट क्लॉक बिगिन, अब अगर स्टार्ट क्लॉक 1 है कंटिन्यूअसली, वाइल स्टेटमेंट किस में वर्क करता है? लेवल में. तो स्टार्ट क्लॉक इफ इट इज 1, सो वी विल वेट फॉर क्लॉक ऑन पीरियड. उसके बाद हम क्लॉक को 0 सेट करेंगे और उसके बाद क्लॉक ऑफ पीरियड के बाद हम क्लॉक को 1 जनरेट करेंगे. ठीक है, कैसे जनरेट हुआ समझ में आया आपको? डिड यू गेट इट? हाउ वी जनरेटेड द क्लॉक? सो इफ यू सी आवर प्रीवियस वंस, यू सी ऑलवेज एट पॉजेज ऑफ द स्टार्ट क्लॉक, मैंने क्या किया? 0 to 1 जब क्लॉक स्टार्ट क्लॉक का ट्रांजिशन होता है तब मैं ऑलवेज ब्लॉक में एंटर कर रही हूँ, और तब जब स्टार्ट क्लॉक अगर 1 है तो मैं क्लॉक को 1 सेट कर दे रही हूँ. और अब मैं क्लॉक ऑन डिले तक वेट करूँगी. ओके, क्लॉक ऑन डिले तक वेट करने के बाद क्लॉक को मैंने 0 किया. सो इनसाइड द वाइल लूप में क्या हो रहा है? एज लॉन्ग एट द स्टार्ट क्लॉक इज 1, हमने देखा कि क्लॉक को हमने पहले सेट कर दिया ऑलवेज ब्लॉक में घुसने के बाद. व्हेन द स्टार्ट क्लॉक इज 1 हमने सेट कर दिया क्लॉक को 1. उसके बाद जब वाइल लूप में एंटर होता है वी विल वेट फॉर हैश क्लॉक ऑन पीरियड. उसके बाद हम क्लॉक को 0 सेट कर रहे हैं. मीन्स फॉर क्लॉक ऑन पीरियड आपका जो क्लॉक था आउटपुट क्लॉक वो 1 था. उसके बाद मैं क्लॉक ऑफ पीरियड वेट कर रही हूँ जब क्लॉक 0 हो, जब तक क्लॉक 0 था. उसके बाद वापस से मैं क्लॉक को 1 कर दे रही हूँ. होप यू अंडरस्टूड. द स्टार्ट क्लॉक इज जनरेटेड टू प्रोवाइड अ skewed output clock, and the skewed output clock would remain 1 for clock on period and would remain 0 for clock off period. Again it would be set to clock 1. If the enable is 0, then start clock will be 0 also, and no longer we will get the output clock. This is what is the code is, and this is how we get the skewed clock of different frequency with different duty cycle and different phase. And here is the end of the module. Now we are writing the test bench for this module clock gen, the test bench with different clock frequency. ठीक है, अभी हम टेस्ट बेंच लिखेंगे क्लॉक जेन मॉड्यूल के लिए जो जनरेट करता है डिफरेंट क्लॉक फ्रीक्वेंसी. सो मॉड्यूल टी बी, ओके, वायर क्लॉक 1, वायर क्लॉक 2, वायर क्लॉक 3, वायर क्लॉक 4. Reg is an enable. Enable is of reg type and delay is of 8-bit. It is also of reg type. Instantiated the clock gen module. U0 is the instance of the clock gen. 2 inputs we are providing, enable and clock 1. Next one, again we are instantiating clock gen module, but now we are changing the frequency, which is a frec, which is a parameter in the clock gen, to 2 lakh value, 2 lakh kilohertz. And instance name is U1 and input is enable and clock 2 semicolon. Then again we are instantiating the clock gen. We are having the frequency frec. We are setting it to 4 lakh. This is a parameter. U2 is the instance name, input is enable and clock 3. Clock gen, again we are instantiating, U3 is the instance name, frequency are setting to 8 lakh. Hash dot frec 8 lakh, okay, and instance is U3 and inputs are enable and clock 4. Again we are having an initial begin end block. First of all we are setting enable to 0. Then what we are doing, we are setting a for loop. for loop, for begin and loop is there. Okay, we are setting a variable I, integer I, and we are running the loop for 10 times, 0 to 9. So I is equal to 0, I less than 10, I is equal to I plus 1. Begin and we are setting the delay to hash random. Hash random is a system task. Okay, it will provide random value to delay, which is of 8-bit. Hash delay enable we are negating. We are setting it to not of enable. So initially it was 0, then it would be 1. After 1 again it would be 0, and it would keep on repeating 0 1 0 1 0 1. And hash display will display the I value, it will display the delay value. Okay, and we will wait for 50 units, and then we will again go to the beginning of the for loop and increment I to I1 it would be, and again we will run the loop. It will continue 10 times. Okay, after 10 times running the for loop, we will come out of the begin and we will wait for 50 time units, and we will call the $finish task. We will end the module. Now I will show you the system simulation log, how it would look. So first of all, you see, initially the frequency was set to 1 lakh. Okay, initial value of the FREC parameter is 1 lakh, phase is 0 degree, duty is 50%. Period from frequency we are getting it from 10 nanosecond, clock on. It would be calculated, we will get it as 5 nanosecond, clock off 5 nanosecond. Quarter, it would be again displayed. Quarter would be 1/4 of clock period. So it is 2.5 nanosecond start delay. Okay, it would be calculated as we saw the equations in the clock gen module, and it is put it as calculated to be 0.000 nanosecond. Now frequency of the clock, next time loop, not next time loop, this is the every time we are calling the clock gen module, we are displaying the because of the $display statement, we are displaying the parameters and all the variable. FREC has been set to 2 lakh kilohertz, then frequency 0 degree, duty 50%, period 5 nanosecond, clock on 2.5 nanosecond, clock off is 2.5 nanosecond, 1/4 clock period 1.25 nanosecond, start delay 0 nanosecond. आप सोच रहे हो, आप देख रहे हो ना, जो सिमुलेशन लॉग है इसमें जो डिस्प्ले स्टेटमेंट था इनिशियल बिगिन एंड के अंदर क्लॉक जेन में, वही सारे डिस्प्ले स्टेटमेंट डिस्प्ले कर रहा है. जब भी हम अलग अलग क्लॉक जेन के मॉड्यूल्स इंस्टेंशिएट कर रहे हैं with different value of parameter, every time we are calling the initial begin end statement inside that clock gen, and we are displaying the all the values of parameters, clock period, clock on period, clock off period, quarter and start delay. So this is how when the FREC is 8 lakh, then also we are displaying the values. For the for loop, which is there in the TB test bench, for I is equal to 0 delay, which was put as $random, it is generating at 36. I is equal to 1, delay 129. Similarly, it is still I is equal to 9, delay is equal to 13. Simulation complete via $finish. So this is the simulation log where $displays of the clock gen are displayed, and also for the for loop also we are generating the test bench for different clock phases. Same test bench which we use for different clock frequency. Okay, module TB, wire clock 1, clock 2, enable, delay. Okay, only the difference is there. What is the difference you see? In the first, when the clock gen first module is instantiated, U0 is the instance name, enable and clock 1 are the input. Then the clock gen again, when it is instantiated, frequency has been changed to 50,000 and phase has been put as 90. So phase change and frequency change. The parameters have been changed. And the inputs are enable and clock 2. Inside the initial begin end statement, initially enable has been set to 0. Then again inside the for loop, it would be run 10 times. Delay is equal to $random. Every time it is generated from the system task $random. Then hash delay, we will wait for the delay time period, enable. Then what would happen? It will not the enable, and we will display the value of I and delay. Okay, this will be repeated 10 times. You see, after hash 50 time unit, $finish statement would be called, and we are ending the module for the test bench with different phases. Similarly, test bench with different duty cycles, same test bench as earlier, except that here we are the duty parameter we are changing. You see, first clock gen instance U0, enable input, clock 1 input. Then clock gen instance name is U1. Duty I am changing to 25. Okay, enable and clock to input. And the last clock gen instance U2, duty has been set to 75. Enable input and clock 3. Clock gen again instance U3, and the duty has been put as 90, duty cycle 90. Enable input clock 4. Again initial begin and statement where for loop has been called. It is run for 10 times. Okay, display of I and delay has been done, and after waiting for 50 time units $finish is called an end module. How we wrote the test benches for different frequency, different phases and different duty cycle. Hope this Verilog code of clock gen is clear to you. If you like the video, please subscribe the channel, please share with your friends, and have a nice day. Bye bye.